is the last one we did. There we go. Number 84. Thanks. Alright, have your integration techniques out. I'm trying to get through the last of this. And then if you guys do have questions on the FRQs, I can go over them briefly. Did you have different FRQs than the ones online? I emailed the answer keys to your response last night. I will the other things I sent you the questions in if you want to. Anyone else? Brendan, you got my email with the new answer keys? You have it, and we talked earlier. And then anyone else? Josh, you had different free responses from these videos. I emailed you the answer keys. You can have it's on top of things. All right, number 84. Kiddos. What forever card must you think of when they're asking for one function value, they've given you another function value and a derivative? There's one forever card that puts all that together. Say it louder. Integration is net change. Says, I will find you an f of v if you can give me an f of a and you know f prime. Integration is net change. Says, I will give you a final amount if you just give me an initial amount, a starting point, and a rate, because then with the integral we can find the change in. So then what is our b in this example? Where are we ending? 5. We're ending at 5. What are we starting with? What did they give us? 1. So then what am I going to put to my bounds of my integral? And who's my derivative? So all I have to do at this point is just say, hey, I know f of 1 and f of 1 is pi. Kiddos, should you do anything by hand after this point? No, the only thing your hand should be doing is punching stuff into your calculator. True? If you guys punch that in, you should get the correct answer of 27. Thank you. 27.81. Plug and chug it to your calculator. There's no work to do that. Is that cool? What forever card is this again? Integration is net change. You can find an amount at a certain time if you have an initial or a starting amount, and you have the rate that you can integrate from or between those 2 points. Okay. So you guys said 80. I have 90. Was there anything else that happened? Someone said something else in the 80s.
Are we going to go to the FRQs?
Yeah. Okay. So we're just going to 90. Is there anything else that you guys want? 90 is the last one. We'll do 90 first, and then if you guys want anything else from A or B multiple choice, be peeking at it real quick. But number 90 is the last one I had circled from yesterday. Every single one of these answer choices, you guys should know this right away. Each of these have H's, but what's the graph of? H prime. So we need to remember this is the graph of the derivative. Probably have y equals H prime of x. H prime is something. I'll just say yeah. 2 semicircles, a common endpoint. X equals 1 is describing the graph, letting us know those truly are semicircles. Which of the following statements about H must be true? Sorry, my mind jumped to number 2 and how number 2 is true, so the derivative exists, the function has to be continuous. We can go back to number 1. H of negative 1. Here's negative 1 right here. To go from 1 to negative 1, or to go 2, 3 from 1. How could we or could we not say that H of negative 1 is equal to 2?
From 1 to 3, H prime is positive, which means H is increasing. But from 1 to negative 1, it goes negative at some point, which means it's decreasing, so it can't be the same. Right.
True. Ryan is seeing is that as you go from 1 to 3, the graph of the derivative is all positive. So the function is strictly increasing. How much is it increasing will be found by this entire area, not just the semicircle, but by the entire area below. So from 1 to 3, h is increasing all the way up to 3. Whereas from 1 to -1, a few of you might get confused and say like, hey, this area is the same as this area, but we have to remember area under the curve. So as we go to the right, it's going to increase this area's amount, which would be rectangle plus semicircle. But as you go to the left, you're going to have that area, this area, and this area, which does not measure up, number 1. And number 2, the way Ryan was describing, remember to go backwards, everything is flipped. So what looks like an increase, what looks like positive is actually negative, what looks like negative is actually positive, what looks like positive is actually negative. But if there's strict increase to the right and there's a little bit of increase and decrease to the left, by different amounts, yeah, there's no way that h of -1 is going to equal h of 3. I kind of already described number 2. But as you guys look at the graph of the derivative, question, does the derivative exist everywhere? Is there a point everywhere between -1 and 3? Yes or no?
Okay.
Yeah. Yeah. The graph doesn't have any vertical asymptotes or any holes. It exists. So if the derivative exists, if the graph is differentiable, what must it also be? If the function is differentiable, if its derivative exists everywhere, then it must be continuous. Yeah.
What if you had like a graph that met each other, but it was like straight? Would it be if -1 to 3 or equal to? Like how would that end up being right?
If these semicircles were shifted down, so it was on the axis, so then the area under one semicircle would equal the area of the other semicircle. Then we could say it would increase by this area, or as you go left, it would subtract the decrease. It would end up increasing. The areas would be the same, so the changes would be the same. Then we could say that those were true. But since this is shifted up and the areas are totally different, we can't say that.
For something like equal to each other like that, do you always look at the area under the curve?
If you have the graph of the derivative thinking about the original.
And what if you didn't have the derivative?
If you have the graph of the original, you would just look at it and say, are the y values the same? Are they at the same height?
Oh.
Does that make sense?
Thank you.
Number 3 talks about a vertical asymptote. The reason it's talking about the vertical asymptote is because there is a vertical tangent line at 1. Because the tangent line goes straight up, and that means that the second derivative has a vertical asymptote, not the original. If the derivative exists, then the function is continuous. So yeah, there wouldn't be a vertical asymptote at 1. So 3 is not true either. The second derivative has a vertical asymptote, which means the tangent line is 1. I would say the correct answer is B. Do you guys back me up? Did anybody find any multiple choice that we missed or that we skipped or that we passed over? Or that you realized you were stuck on last night? We're peeking. As they're peeking, some of you guys were wondering about FRQs. Is there anything where we got lost on the FRQs?
I had a really quick question on the honeybee one.
Okay. I'll ask one more time about multiple choice. You guys want to keep on looking. Is that number 6?
There's 9. The last one.
Okay.
Number 6.
Okay.
Is that? Yeah. Part C.
Alright, so first of all, just reminding all of us what's going on. We have a hive with bees initially, and then we have bees entering by the rate E. So that's like a derivative of how fast they're coming in, or the rate of how fast they're coming in. And then we have, that's a rate, the rate of how fast they're leaving. And some of you missed that. It's measured in hundreds of bees per hour, not just bees per hour. Hundreds of bees per hour. Wait, was this Ajax? Yeah. She's like, I think I'm not putting hundreds. Okay, part C. The minimum number of bees in the hive. you have a specific question about it, Ryan, or just want me
Yeah, so the function that you have to get for the total number of b's is 35 plus the integral from 0 to 4 of e of t minus l of t. And then you derive that, right, to get the rate to make a sign chart.
Because you can say the number. Yeah, and when you derive 35, it just goes away, right? The number of b's at a certain time is going to equal the initial number of hundreds of b's plus the integral from 0
0 to 4
to, I'm going to say t.
Okay.
Just for sake of.
of e of t minus l of t.
Oh, that's right, you guys had t, so you can say x. Well, I'll just do t's, and then we'll do e of x. So that's the expression of how many b's. And then you can define n prime set equal to 0 or d and e, but there's nothing you can do for numbers of b's. And then test critical numbers and endpoints. It should put it a little bit differently in there.
So once you get that and derive it, you get down to the function negative 3t squared plus 18t minus 15.
And that's after plugging in e and l.
Yeah.
What was it, 16t minus? Keep reading it for me.
Minus 3t squared plus 2t minus 15. And then, yeah, minus 2. Yeah, that's good. That looks right.
Does that work? And then it distributes.
So, like, once you simplify and factor it down and all that nonsense, you get down to t minus 5 times t minus 1.
Because you're factoring, right?
Mm.
Everything by a negative, you call it a 3, and everything, you end up with t squared minus 6t minus 5 is 0.
Right.
So what am I signing off?
I think so. Yeah, because it's negative 15, because the negative distributes.
That makes more sense. So minus 1 and then minus 5.
Mhm.
Okay, good.
And then it's EVT, which means set at an endpoint or a critical number.
Right.
And 5 isn't in the set, so it's either 0, 1, or 4.
Right.
But when I made a sign chart for it, t equals 1 was a max.
Was a max or the max?
A max.
That's awkward.
Yeah.
Is that where the minimum ends up occurring?
Yeah.
According to.
So like when I was doing the actual exam, I saw that. I said, oh, t equals 1 is a max, throw it away. It's not that.
Right, because you could just discount it entirely. So you're doing 0, 1, and 4, 5 doesn't matter. You're plugging into n prime, right?
Mm-hmm.
So if you plug in 1/2, you plug in 2. When you plug in 0, what you end up being is 35, right?
Yeah.
When you plug in 1, how many do you end up being?
28.
Yeah. How about 4?
55.
55.
55?
Yeah.
I'm just double checking the sign. What on earth? the solution to that? We want to separate it. There you go.
Go back to the formulas.
Yeah, that's what I'm gonna do. 16t minus 3t squared. That was entry.
What is the next one? -2x.
Negative 2t plus 1. Put it down. Don't want to waste lots of time on it. I will see it right away, but I'm not sure when. I know looking at it that there's something that's unresolved.
Alright.
What do you see?
If you graph the two lines for that
Yeah.
integral, at 1 they switch top and bottom. Would that be it?
No, it makes sense they switch top and bottom, but it depends on which one switches. So seemingly, from 0 to 1, they're entering faster than they're leaving, which means that more are coming in than are going out. Is E on top and L on bottom? To the left.
Was E -2x plus 15? Or no?
E was
Yeah.
16.
And E was 16.
Alright, E is on the bottom until 1, and then after 1 is on top.
Okay, so hold on. It's negative then positive. Somehow our signs are flipped. Why? Oh, wait a minute. Wait a minute. Ryan, when we set equal to 0 for the critical numbers, we discounted the -3, but if we're plugging into the derivative, we need to have the -3. That was the problem.
Oh.
So when we solved for the zeros, we divided by the -3 and ignored it. But when you plug back in, you have to plug into the actual derivative itself, and the actual derivative itself.
I would have flipped the signs because the
You
negative.
flip the sign.
Okay.
The negative.
I was so lost. I was so confused. I could not figure it out.
There you go.
Alright.
We need to make sure to plug into the entire derivative, not the simplified after we set equal to 0 derivative. Does that make sense?
Mhm.
Lol. I was going to say that's impossible. And it was impossible, we should find it. Okay. Yeah, I that now would have been stuff too, in the sense of five components. Okay. Anything else in the free response?
Yeah.
Which one?
I actually just had a quick one on number 5A. Oh wait, no.
What is the piecewise rearrangement?
Yeah, but wait, hold on.
While she's looking at that, did they find any multiple choice in this?
I don't have one from 6.
I would like to use it. No, sorry. Oh, yeah. Rich, have you found it yet? You can keep looking. We'll go to 26. Oh, it's 27?
Yeah.
Alright, let's take it 26 and 27. We're adding these questions real fast. 26, if you forgot what to do once you have an improper fraction in an integral, you're going to be totally lost. What do you always do when the degree on the top is higher than the degree on the bottom? I would write yourselves a little note. You always divide. That's the struggle. Improper fractions, when you have degree on the top higher than degree on the bottom. That's right, I did this after school last week. Long division, so you multiply, x times x is x squared. Get negative 3x minus 5, make sure you distribute that negative. That was another common mistake that people found. Then you have negative 3. Distribute that negative. We can rewrite this function then, since we have this remainder of 1. And we rewrite that 1 over the denominator. So we can change this integral to be x minus 3 plus 1 over x plus 2. And then we integrate piece by piece. Integrate the x, integrate the 3, integrate the 1 over x plus 2. Integrating the x is just power of 1 half x squared. Integrating the 3 is just minus 3x. For this little guy, you would need to think about u sub. Separately from the rest, you don't have to have a u for everybody. It can just be for one piece when you have sums and differences. Du ends up just being 1 dx, which means no big deal. I can think of this as the integral of 1 over u. Du. And what's the integral of that? Ln of x plus 2. And since we haven't stayed in u's, we can just use those cool little x values of 1 and 2. After some pretty quick plugging in, 4 over 2 is 2 minus 6 plus ln of 2 plus 2 is 4 minus 1 half minus 3 plus ln of 3. And 2 minus 6 is negative 4. 1 half minus 3 is negative 5 halves. Negative 4 can be rewritten as negative 8 halves. Negative 8 halves plus 5 halves plus ln of 4 minus ln of 3. Sad thing is you have to remember the logarithmic rule. What happens when I have two logs being subtracted? I need to divide. So it's going to be ln of 4/3, and to be honest, there's only one that even has that. So when you subtract negative 8/5 and 5, sorry, negative 8 halves and 5 halves. Good question. If you didn't remember to log divide, that thing would have been impossible. So at least it would have been very attractive. Number 27. Classic related rates. And some of you were like, I hated the words and I got lost. But you have to think they've given you everything you need. So when they say the area of the surface is, they give you an equation. They give you that h is depth. Your meters and square meters. You have this radius of 6. It says when the height is 3 meters, the depth is decreasing at a rate of, guys, you've got to get these words in the math. When they say the depth of the water is decreasing, we can say dH dt. What is depth? H. So the depth is decreasing at a rate, that's a derivative, dH dt. Decreasing is negative 1/2 meters per minute. They're asking you to find at that instant what is the rate of the surface. They want you to find, well, surface, if you guys look up above, surface is A. So find dA dt, find the rate of A. And they said at that instant, so when h is 3, I guess? Ignore the picture, ignore all the craziness. You just say, do I have enough to take a derivative with respect to t with an a and an h? Yep. I have an a and I have h's. Just take the derivative. ddt of everybody. If I take ddt of both sides, good catch on this one, guys. Maybe 6 and 1. dA dt is equal to derivative of a is 1 dA dt. Derivative of 2 pi h, sorry, 12 pi h is 12 pi. Derivative of h is just 1 times dH dt. Implicit differentiation. Derivative of pi h squared, pi is just a constant, so bring down the 2, keep it with the pi, h is to the first power of dH dt. And then what is this that we need to do now? Plug it in. Oh, there is no plug it in over there. Plug it in. We get negative 1/2 times 12 is negative 6 pi. Minus 2 pi times 3 is 6 pi. Times negative 1/2. Which ends up being what? Negative 6 pi plus 3 pi? 1 minute is Oh, it says decreasing. It says decreasing. So if it says decreasing, do I need to put the negative for my rate? No. Decreasing is the negative. So I could say it's decreasing at a rate of 3 pi. That's what the negative symbol is. Bridget, did you find that effort here?
Yeah. It's on number 2C. I just want to show how they used MDT.
Is this the? Oh, got it. It's all in the wording. We know a position at 1, we know a position at 3, and then it says the velocity must be 2. What's the relationship between velocity equaling 2 and position? Is it velocity the derivative? And so if velocity is the derivative of position, guys, what theorem says there must be a time, there must exist an x equals c such that the derivative is equal to a number. Not moles, that would be the derivative equal to 0, which one says derivative equal to number? Good. So we say, well, we really hope this works because all they gave me was x of 3 and x of 1, so I'm going to try to do MVT, which talks about the derivative of position, which is velocity. You plug in by faith and say, all right, they gave me these two numbers for a reason. Is this going to end up being what I need it to be? And the answer is yes. So when they said, hey, I'm giving you positions, must there be a time when velocity had to say, oh, velocity is the derivative. Derivative, that's MVT. And then you just use the points they gave you. And then you should say something to the effect of, since position is continuous and differentiable, that's the condition of MVT. By MVT, by mean value theorem, there must exist a time, and then just steal their wording. There must exist a time t in between 1 and 3 at which x prime is 2 or velocity is 2, either one. Since x of b minus x of a over b minus a is equal to 2.
Another question is on 4B. I think it was Gerardo's, and after his second step, I don't know how he got to as the limit approaches negative.
Oh, is this the exponentially one? Okay.
I didn't know how he got to g of x equals 2. He didn't show where.
Hey kiddos, real quick, if you weren't able to get letter A on the actual AP, what have I told you to do in order to be able to go to B even if you haven't gotten A? Let's say you got stuck somewhere in the integration. You're supposed to solve A with separable differential equations. Let's say you got kind of stuck. You're going to have a miracle occur on your paper. You're going to do a dot, dot, dot. You're going to show me an answer of y equals. And then for letter B, you take the limit of whatever answer you write. And if you did it correctly, you get the equation. So even if you get A wrong, make a good answer for it because then you can just take the limit of B. But anyway, all that's going to be effect of. In this one, we're talking about how to take the limit of the right answer. What was the right answer for y equals g of x in part A?
As the limit approaches negative infinity, 2 plus 3e to the 1/3 x cubed plus x up top.
Like that?
Mm-hmm.
Okay. If you're trying to take the limit of this, I think we did in the when you see you think. I had you guys write down, watch out for exponential functions when you're taking the limit to infinity. I think I talked about it in context of horizontal asymptotes. You guys thought there was only one horizontal asymptote when there were 2. Exponential functions work differently as you go to negative infinity versus positive infinity. If I'm taking the limit as I approach negative infinity of 3e to that. Now, first of all, we could go ahead and say that the limit of 2 is just 2. So we can just write 2 plus. The limit of a constant is just the constant. It stays the same. But now I have to think about the limit. I'm going to pull the 3 out as x goes to negative infinity of the exponential. Where is the negative infinity getting plugged into? The exponent. The negative infinity is getting plugged into the exponent. Let me try to show you what's going on here mathematically. If the limit as x goes to negative infinity is of the exponent, I could rewrite this problem and put the negative in and say that's the same thing as the limit going as x goes to infinity of e to the negative 1/3 x cubed plus x. I'm not doing my soft math. If I was going to do my soft math, I'd put the little negative infinity here and put the little negative infinity there. Both of these end up becoming a negative power. The reason I'm showing you this is because whenever you have a negative power, I brought the negative from the infinity up into the power. What's true whenever you have a negative and a power? Just from pre-calc, from algebra 2, from algebra 1. Over a negative and an exponent. Isn't it 1 over? So it's 1 over e to the blah, 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 blah. If you're approaching negative infinity, and it's going into the power, and it makes the entire power negative, which it will, that means it's the same thing as 1 over. Now think if I plug in infinity and it's 1 over, well, who wins, top or bottom? Bottom wins. And if the bottom wins, what's the limit? 0. So we can say this all goes to 0, so you end up with 2 plus 0 is 2. Now I'm showing you the idea behind it. My fuzzy math would have just been plugging in negative infinities, pulling the negative out, putting 1 over e to the infinities and saying, hey, it's 0. Both ways technically work. This one's probably a little more mathematical. But there you go. All right, kiddos, with this, you might have some extra personal questions. If so, I'll be here at a quick team DR meeting right after school. But then I'll be available after that. We'll be longer than 20 minutes, maybe 15, if everybody gets there. But after that, I'll be available for questions, and I'll be here during lunch. Oh, it's signing day for seniors on senior patio. We'll see. If you guys have your corrections ready to go, let me have you guys do the following. You see how many paper clips I have?
Ice cream's in.
Oh!
Alright, if you guys are ready to turn yours in, I want you just to walk back to my desk, paper clip your entire exam together, including your Scantron, and then you can go throw it in your tray back. If you're not ready to by the end of the day, unless you guys took it later and you had a different version of the exam because they didn't have quite as many resources to correct theirs as you guys. Got a paper clip off my desk, paper clip the whole thing, Scantron, multiple choice A, B, and FRQ. We are going to integration techniques.
I was so sad leaving on the plane. I was like, I was so bitter.
I saw that and then Emily told me that we were walking like right up the phone and she was like, I didn't see anything.
We were gonna.
I heard actually, but okay.
We were gonna.
Your face? Yeah, that's gross. Yeah, my red pen. But we wanted to be kind of like
Kiddos, if any of you guys were sick on the day that we passed it out or you were gone and so I gave it to you later, I think I did have one no-name extra version B, and I have 2 people who are now desperately hoping it is theirs because they can't find their version. If for any reason in your stuff you got an extra version B, please let me know. Otherwise, they're kind of out of luck. In the sense of Alright, cool kids, integration techniques, here we go.
Yeah, a question. There's three. Okay. I did the work and then I went to check it, and it wasn't C, it was D, but I don't know how they
Ooh, okay, so you knew it was sign in first, right?
Yeah.
Okay, so then you made u equal to 2y balance, is that right?
Yeah.
Okay. And if we're trying to plug in, once we make u equal to 2y, we can do 1 over the square root of 1 minus u squared. However, when we do u sub, what else do we have to consider? So whenever you choose a u, you have to go to du. So what's du of 2y? 2 dy. Divide by 2, divide by 2. So in order to do this legally, to get a du, I have to incorporate a 1/2. Does that make sense? And then at that point, we can go ahead and make it positive 1/2. There you go. So, good question. I know some others of you got started working. Did you get stuck anywhere?
Oh, on the second one, I wasn't sure where to start.
Okay, the second one is a mess, right? Some of you guys might think arc trig, but why are we going to try to not do arc trig? There's grossness going on, right? So then with the grossness going on, maybe we could go ahead and try to set the inside to be u, because we have a y in both places. Okay, so if we set the inside to be u, there's not like a 1 under there, so we're hoping it's not arc trig. 2y minus 3y squared. Now guys, to be honest, these are hard integrals just to see if you know how to face hard integrals. Du would be 2 minus 6y dy. Okay? And so we would go ahead and divide both by 2 minus 6y. When plugging in, we would have 1 minus 3y we don't know what to do with. We have u to the 1/2 for the square root of u in the denominator. And then to plug in, I have du over 2 minus 6y. Now at first look, they don't match. If you look a little closer, what can I pull out that's in common? Exactly. So I can go ahead and factor out a little 2 from the denominator. So I would have du all over 2 times 1 minus 3y. Some of you would show more work than others. Don't forget that little 2, that's going to be a 1/2 is in the denominator. Integral u to the negative 1/2 du. And to be honest, at this point, kiddos, can't you automatically say the ln's? No way, Jose, that doesn't work. We know there has to be a 1/2. But the dilemma is, struggle when we integrate, we need to actually integrate this. So that would be u to the positive 1/2 over 1/2 is times 2. I can go ahead and cancel. And we're just going to end up with the square root of. The part of the answer is e. Does that sound right? You guys found this under the keys. Remember, it's in the handouts folder, the keys folder, integration techniques, laying the foundation.
Are we only referring to the odds or?
Odds are the required evens or bonus, just like always. Any other questions on odds? We have about 5 minutes. 17? Okay. So you're going to zoom up to 17.
When you're done, can you go back to 4?
You guys notice there's no FRQ on this one, right?
Yeah.
And then go back to 4?
Yeah.
Oh no! Who's you on 17?
The square root of x.
Choose the power. He's the innermost. I know we usually choose a denominator, but that little innermost, he's got us all tied up in knots. We have to think about the integral of a to the u or b to the u with that little 2 to the u. So u does equal square root of x. Du equals 1 over 2 square root of x dx. So dx is equal to, I'm going to plug in. I'm going to ignore the bounds for right now. Maybe we'll do u bounds, maybe not. You guys notice when I plug in the 2 square root of x dx. cancel, which is nice, and I have T to the U. I apologize, that's B. Just to make life easier, I think U-bounds might be nice, plus you guys all missed the U-bound question yesterday, so let's go ahead and throw that in. Not all, a lot of you missed the U-bound question. So you want to get this totally in terms of U, square root of 4 is 2. Square root of 1 is 1, so we can do 1 to 2. Ah, forever card. What is the integral of A or B to the U? How do you memorize it? The derivative of B to the U is B to the U times L to B times U prime, but the integral, we have to compensate for the ln of B. So it's 1 over ln of B times B to the U. We have to compensate for what would happen in the derivative. Then we have our 1 to 2, which means we're going to have 1 over ln of 2 times 2 squared minus 2 to the 1. Is that right? 4 minus 2 is 2, so we end up with, I think, 2 over ln of 2. We cannot simplify because one of them is in an ln. We can check the answers real quick. Number 17. Got it. Bridget, you said which one? Number 4?
Yeah. I ended up getting stuck. I had like cosine squared. I don't know, it just making confusing.
Ugh. Would we make U 3x?
Yeah.
Do we have an integral rule for 1 over cosine squared? Could we make U cosine? Du would be sine. There's no sine here. Could we make U cosine squared? Gotta go back to pre-cal and say, what is 1 over cosine squared?
Oh, secant.
Oh, secret.
Struggle. Why does everything change as soon as we have a secant squared?
Derivative tangent.
Oh. U was 3x.
What?
Because 1 over cosine squared is just secant squared, and secant squared has a nice integral. So we divide by 3, we end up with 1/3 the integral of secant squared of U du. Which is going to be 1/3 tangent. I'm going to go back to x's this time just so I can keep my x term from 0 to pi over 4. It's going to be 1/3 tangent of 3 pi over 4. There's tangent of 0. Tangent of 0, which is 0. Tangent of 3 pi over 4. Oh, that's 45 degree in the second quadrant.
-1.
Nice thing is, no FRQs tonight. Just play with integrals. Come tomorrow with questions. First thing, we'll see what integrals you weren't able to get. Odds, do those first. If you have time. Fractions due by the end of the day. If you guys have any particular problems, come talk to me. Don't just cheat your way through it. Bye, guys.
So when you integral these variables,